Next application. Next application. So this is the role of what here? Hyperconjugation in the heat of hydrogenation. Hyperconjugation is entirely what here? What is the relation? Inversely proportional to heat of hydrogenation. So first you need to find the stability based on the hyperconjugation, then opposite direction, opposite trend is what here? Heat of hydrogenation. Next application is what here? Dipole moment. Next application, dipole moment. This dipole moment mostly we may observe in carbocation. First one, dipole moment is nothing but what here? Charged particle. Charged. Maybe actually charged, not partial charged. Partial plus or minus, that we have to choose. But here of course more charge is there, so more dipole. So dipole is what here? C plus charged particle. Now how to find this dipole moment based on the hyperconjugative? One example like methyl carbocation, ethyl carbocation, methyl carbocation, ethyl carbocation, isopropyl carbocation, and tertiary butyl carbocation. 4 carbocations are there. Now, so which molecule is having the maximum dipole? Maximum dipole, which means more charge. More charge. Which one is having? Same. This is the based on which one? Hyperconjugation. Hyperconjugation here. How many alpha hydrogens? 0 alpha hydrogens. Am I right? 0 alpha hydrogen. There is no hyperconjugative condition. There is no alpha CH3 condition itself. Now here carbocation alpha CH3 is there. How many alpha hydrogen you are getting? 3 alpha hydrogens. Here how many alpha we are getting? What? 6 alpha hydrogens. Here how many alpha we are getting? Here 9 alpha hydrogens. Now so here charge, we have to focus on the charge. We have to focus on charge here. 3 alpha hydrogen, which means here 3 times it is getting neutral. This one, this carbon, we have to focus on this carbon. So here carbon, here carbocation is there. So this carbocation, of course here due to hyperconjugation, structure would be like this. Am I right? So what is the charge of this carbon beta? 0. After hyperconjugative structure, what would be the charge of this carbon? This carbocation is being converted to what here? C0, which means neutral. So this kind of neutral, how many times we are getting? 3 times we are getting neutral. Here I am how many times? 6 times we are getting neutrality. Here we are getting how many times of this carbocation? 9 times. So most of the times it is getting what here? Neutral charge because of more number of alpha hydrogens. If it is becoming more neutral, then dipole moment, generation of charge, what happened here? Decrease. Very less charge would be present on this carbocation because of more number of hyperconjugative structure. So that's why, what is a dipole moment? What is a dipole moment? Dipole moment order here. Dipole moment order is what here? First one, which one beta? This is what? Nearly neutral. This one is, there is no hyperconjugation, complete positive charges existed. So that's why you can say here this one, the next one is what here? 2, next one is what here? 3, next one is what here? 4 to 1. So this would be the order 1, 2, 3, 4. 1, 2, 3, 4. This would be the order of dipole moment. Of dipole moment. Check it. Of dipole moment. It's nearly 0. Many times it is getting 0 charge. 0 charge. 0 charge. Okay. So this is what here? Dipole moment. Hyperconjugative applications. Hyperconjugative, of course, after knowing this kind of concept, first we need to find what here? Alpha hydrogen. Okay. If we need one more example. So alpha hydrogen C plus is there. Alpha hydrogen CC plus. Next one is C. Next one is C, like this. Right. Now how many alpha hydrogens here? 3 alpha hydrogens are there. Here how many alpha hydrogens? 6 alpha hydrogens. Here how many alpha hydrogens? 5 alpha hydrogens. Here how many alpha hydrogens? 4 alpha hydrogens. Of course you may derive here dipole moment. The dipole moment is depending upon alpha hydrogens. Dipole moment is inversely proportional to number of alpha hydrogens. Number of alpha hydrogens. Dipole moment is inversely proportional to number of alpha hydrogens. Then you can find yourself. What is the order? What is the order? You can find yourself. So lower number of alpha hydrogen 3, 6, 5, 4. So this one would be the first, right? Next here 4 number of alpha hydrogen, next 5 number of alpha hydrogen, next one 6 number of alpha hydrogens. So more number of times it is getting neutral charge. That's why it is what here nearly, like compared to other things, it's nearly what, neutral. It's nearly neutral. So this is the application of dipole moment. Application of what here, dipole moment. So dipole moment is over. Next one, heat of hydrogenation. Next one, stability of alkene, stability of carbocation, stability of carbon radical. So next one, heat of combustion, that we will discuss later. Heat of combustion. And one more factor is there, one more factor here, note. So carbonium will never show what here, hyperconjugation. Carbonium will never show. For example, here carbonium is present, so it is having like alpha CH3. Now there is no hyperconjugation. There will never be hyperconjugation. Why? So this carbon is having already one LP. This carbon is having already one LP. Next, this carbon is having actually CH bond. So here, due to En difference, it is liberated as H plus, which means here bonded electrons are polarized towards carbon. So this carbon is also having what here, LP. Electron density, both are electron denser. How it is getting overlap? There should be mutual understanding, right? Here electron rich, so there would be no overlappation. Such kind of overlappation is not observed. That's why a carbonium with alpha CH3, even alpha CH3 will never show what here, hyperconjugation. Will never show hyperconjugation. So this is also very important point. So you have to observe sp2 atom. Okay, we have to observe what here, radical, carbon radical, carbocation, alkene. Only three things. The stability of these three things. Next one, apart from stability, alkene, heat of hydrogenation, alkene, heat of combustion, and carbocation dipole moment. Carbocation dipole moment. So these are the overall applications of what here, hyperconjugation. So now hyperconjugation is over. So next parameter, next effect is what? This effect is the most important effect. That is what here, resonance. What is that here? Resonance. There are many definitions. Resonance. Simple words. What is the definition of resonance? Simply, what is the resonance? So delocalization of either pi bonded or non-bonding electrons. Pi bonded or non-bonding electrons. Pi bonded or non-bonding electrons in a conjugative system. In a conjugative system. In a conjugative system. So this system is very important in the resonance. To show resonance, the system should be in what here? Conjugative. To show resonance, first parameter is what? Whether the given structure is having conjugative system. It is not conjugative pi bonded system. Conjugative system. What is the difference between conjugated pi bonded? Next one, conjugative system, that we will see later. So here conjugative system, whether it is conjugative system or not. First parameter. Second one, so here of course pi bonded you make it easily, but these non-bonding electrons are there. What kind of non-bonding electrons? What kind of non-bonding electrons? You may observe like a normal condition, delocalization of only pi electrons. No, it is absolutely wrong. It is not only pi electrons. Either pi or non-bonding electrons. Either pi or non-bonding electrons in a conjugative system. First, let's see what is this conjugative system. First, let's see this. What is this conjugative system? So, first pi bonded systems. First pi bonded system. There are three types of pi bonded systems. Beta. Pi bonded systems are three types. First one is what? Isolated pi bonded system. Isolated pi bonded system. Isolated pi bonded system, which means here any two pi bonds are separated by at least two sigma bonds. At least two sigma bonds. Any two pi bonds, any two you can take in the molecule. This is about only pi bonded system. It's not about charged particle like carbocation and carbonium. Only pi bonded system. Okay, we are discussing first of all what here, pi bonded system. So right now the two pi bonds, any two pi bonds are separated by at least two sigma bonds. then the system is said to be what here? Isolated system. Let's see few example, right? Isolated system. Now here C double bond C, next one carbon, next one carbon, next one pi bond is there. Now here two pi bonds are present. These two pi bonds are present here. These two pi bonds are separated by how many sigma bonds? How many sigma bonds? Two sigma bonds. How many sigma bonds? At least two are required. Two are more than two. Okay, no problem. But at least two requires here. Two sigma bonds are required now. At least two sigma bonds are present. That's why this pi bonded system is called. This pi bonded system is called what here? Isolated pi bonded system. Isolated pi bonded system. You may take any system. At least two pi bonds. Like this, you can take like this. Here also. Sorry, already two pi bonds. Sigma bonds are there. One more. Here. Yes. Two sigma bonds are there. 1, 2, 3. It is separated by how many sigma bonds? So here 3 sigma bonds are there. So yes, it is also isolated. Cyclic system is also possible. Cyclic system is also possible. Cyclic system is also possible. Like this cyclic system is there. Now this pi bond is separated by how many sigma bonds? 2 sigma bonds. Yet yes, it is also what here? Isolated. It is also what here? Isolated. Yes or no? Yes or no? No. Cyclic, you must be careful here. Cyclic, two propagations are there. Cyclic, two propagations are there. Here this double bond is having single propagation, single direction, in this direction only. This double bond is having in this direction only. But this double bond is having two directions. Now see these two pi bonds are separated by in this way single sigma bond only. So it is not isolated system. What kind of system, that we will see later. It is not isolated system. Okay, is it clear beta? Any propagation, at least two sigma bonds should be there. If there is only one sigma bond, that is not at all isolated system. That is not at all isolated system. Now one more example in cyclic with the two propagations. Now check it. What is this? Is it isolated or not? Yes, first propagation in this manner. In this manner, now here one sigma, two sigma bonds. Okay, it is satisfied. Upper one is also here one sigma, yes. So any direction, these two pi bonds are separated by two sigma bonds. That's why it is also what? Isolated pi bonded system. Isolated pi bonded system. Whatever you may take here, 3 member, 5 member, 6 member, 7 member, like this. Now here also in between these two sigma bonds. In this way 3 sigma bonds. Yes, it is also isolated. It is also isolated like this. So this is called what here? Isolated pi bonded system. We are discussing only pi bonded, not the normal conjugative system. Okay. So now here isolated pi bonded is over. Is it clear? Isolated. Second one is what here? Conjugative pi bonded system. Conjugative pi bonded system. Conjugative pi bonded system. So it is very simple. Now any two pi bonds are separated by only one sigma. Only one sigma is important. Only one, not at least. Not at least. Only one sigma bond. Any two pi bonds are separated by only one sigma. So this is the conjugative area. Okay, area we have to say, not molecule. Sometimes all the molecule is participated. Sometimes here certain area is only participated. That we have to choose here. Conjugated pi bonded system or conjugated pi bonded area. This term is very important in the delocalization. What does it mean, that we will see. First one is what? Simple example. C double bond C. Next one sigma bond. C double bond C. Yes. So here these two pi bonds are separated by only one sigma bond. Yes, it is what? Conjugative system. One more example. C double bond C. C sigma bond C double bond C. C sigma bond C double bond C. Yes, it is also conjugative system. It is also conjugative system. Here one sigma bond is there. Here one sigma bond is there. Any two pi bonds are separated by only one sigma. So these two by only one sigma. These two by only one sigma. Yes, complete system. Complete means this is a complete area. This complete area is what? Conjugated area. If you take like this C double bond C, C double bond C, C and C, whether it is conjugative or not, whether it is conjugative pi bonded system or not. Yes, it is conjugative pi bonded system. So actually here two sigma bonds are there. Okay, no problem. Two sigma bonds are there, no problem. But here what we have to choose? Area. What is the conjugative area? Up to this one, this area is what here? Conjugative area. Remaining whatever. Sometimes you may get the conjugative area. Sometimes you may get what here? Isolated area. Which means here one more example. One more example. If you check here, C double bond C, C double bond C. Next sigma sigma C double bond C. Now this area is called what here? This area is called what here? Conjugative area, because two pi bonds are separated by only one sigma bond, only one. But these two pi bonded, what here? These two pi bonds, here one, here one. These two pi bonds are separated by two, at least two or two. This is what here? Isolated area. So you would not say directly here. So one thing here, maybe area is important. So this area is what? Conjugative area. This area is what here? Isolated area. That's why area is very important. In that area it may be delocalized. That condition is what here? Conjugative system. Okay. We are not discussing conjugative, only pi bonded systems. Okay. Pi bonded conjugative system is over. Next one, pi bonded isolated system is over. Next one is what here? Cumulative. Last one is what, beta? Cumulative. Last one, cumulative pi bonded system. So pi bonds are not separated by sigma bonds. Pi bonds are not separated by sigma bonds, means continuity would be there. So these cumulative pi bonded systems are called allenes. Very important in geometrical and as well as optical isomerism, which means here stereoisomerism. This term is very important. Allenes are two types here. Allenes are two types here. Odd allene, even allene. Odd allene what here? Even allene. Odd allene is nothing but depending upon the pi bonds. Here also depending upon the pi bonds, you could say odd allene or even allene. So one example is what here? C double bond, C double bond, C double bond, C. Now no pi bond is separated by at least one sigma bond or sigma bond. Here pi bond, here pi bond, here pi bond. This is called what here? Cumulative or allenes. How many pi bonds are there? 3 pi bonds are there. That's why it is called what? Odd allene. What is the name of this one, beta? Odd allene. Next one is what here? C double bond, C double bond, C double bond, C is there. Next one more double bond. If you take, of course, this complete system, this complete area is what here? Cumulative area, allene area. How many pi bonds are there? 4. That's why it is what here? Even allene. This is called what here? Even allene. So these are the pi bonded systems. Isolated, two pi bonds are separated by at least two sigma bonds. Next one is conjugative, only two pi bonds are separated by only single sigma bond. Next one is a cumulative or allenes, so no pi bonds are separated by sigma bonds. So this is the system of pi bonded system. Only pi bonded system is over. Next we have to go through this one. What is conjugative system? This is very important. What is conjugative system? That we will see in the next video. Okay.